Good morning students. Today we will discuss about Kirchoff's laws and then we will discuss their applications. So, according to Kirchoff's first law, the algebraic sum of all the currents meeting at a point or meeting at a junction is equal to how much? 0. So, in this law, we are discussing about the currents and junction. That's why first law is also called as the junction rule or junction law. Now, what do you mean by this? For example, suppose A is the junction. This is I1, this is I2, this is I3 and suppose this is I4. So the most important thing is the sign conventions, means when we will consider the current to be positive or negative. Remember, the currents coming towards the junction will be marked as the positive directions. Like I2. What is the direction of your I2? Direction is towards the junction which is your A. So, we will consider here I2 as positive. For example, I1. What will be the direction of I1? I1 means it is away from the junction. So, I1 will be considered as a negative. Similarly, I3. The direction of I3 is away from the junction. So, I3 will be also marked as a negative. Last, that is your I4. What is the direction of I4? I4 is towards the junction. So, towards means I4 will be positive. So, in other words, according to first law, we can write down the amount of current entering into the junction is equal to the amount of current leaving the junction. That means I2 and I4 both are entering into the junction, and I1 and I3 are leaving the junctions. So, algebraic sum of currents means I1 plus I2 plus I3 plus I4 is equal to 0. But you have to use your sign convention. That's why you can write down I1 and I3 both are negative. So, minus I1 and minus I3. I2 and I4 are positive. Or you can write down here I1 plus I3 is equal to I2 plus I4. So, this is your first one. And it is based on the conservation of charge. Because according to first law, we are discussing only about currents. Now, come to the second. second law is also called as a loop rule. Loop rule means you have to consider, or this law can be applicable to the closed loop. So according to your second law, the algebraic sum of the changes in potential difference is equal to 0. Means algebraic sum of the changes means small changes in potential difference is equal to 0. Or in other words, you can write down the potential difference is equal to the product of your sum of your product of current and resistance. Now, what do you mean by this? For example, suppose I am drawing a circuit where 3 resistors are connected. This is your resistor R1 and this is E1. This is your second resistor R2. And this is R3. Clear? A, B, C, D, E and F. Now, for this A, B, suppose the current is here I1. And for resistance R2, suppose the current is I2, and mark the directions. This is I2 and here I1 plus I2, and the direction is from C to D. Through the resistance R3 is flowing. This is E1 and this is E2. Clear? Now, according to the direction given in this diagram, we can show by this. Similarly, for this loop, second loop, then the direction is like this. That means mark. There are 2 loops. One is A, B, C, F, and second one is F, C, D, E. Clear? So, 1 and 2. So, A, B, C, F. Clear? Or A, B, C, F loop. According to your second law. E1, but here the direction is in your opposite directions. So the change in potential is equal to E1 minus E2. E1 minus E2 is equal to how much? Current is here I1 and resistance is here R1. So I1, R1, and here the current is I2 and R2, but the direction will be in opposite directions. So E1 minus E2 is equal to I1 R1 minus I2 R2. Similarly, for C, D, E, F, or C, D, E, F loop. here the resistance is R2 and the current is I2, and for resistance R3 the current is here I1 plus I2. So we can write down E2, only single cell is used. E2 is equal to how much? I2 R2, I2 R2 and I1 plus I2 into R3, and the direction is in the same direction, so that will be a plus I1 plus I2 into R3. Clear? So in this way we can apply the second rule, which is called as a loop rule also in various situations.